Hi guys, let us recall the video on the law of large numbers. We did see in that video how if we flip a coin several thousand times, we would get 50% of the times heads and 50% of the times tails. In the next video on expected value, we considered a scenario. We called it game 1. The game involved flipping of a coin. So, if the player plays this game, he will have to give no charge. There is no fee to play this game. If the player gets heads as a result of flipping a coin, he gets $10. And if he gets tails, he loses $8. We calculated the expected value for this game and we got 1. And we ran this simulation and we saw that if this game is played several thousand times, we would get expected value as 1. Initially, it would go through the turbulence, but slowly and slowly it will settle at 1 as the number of plays increases. So now what we will do is we will change this scenario, game 1. This scenario we will change and we will call that as game 2 or scenario 2. So to play this game, there is a charge of $6. If one gets heads, there is a win of $10. If one gets tails, he or she loses nothing, that is $0. So let us calculate the expected value for this game. So we know the probability of getting heads is 0.5. Now, if we get heads, what we are going to win? We will win $10. Okay. Then, what is the probability of getting tails? 0.5. And if we get tails, what we are going to get or what we are going to lose? 0. Okay. So we know how to calculate the expected value. Probability multiplied by all the values of random variable. So we are multiplying it by 10. First probability is 0.5, that is for heads. Second probability is 0.5, that is for tails. And they are getting multiplied by their respective random variable. So let us run this. 5. Is this the result? No. Let us consider the fee amount also. One has to pay a fee of $6. Now what is this? If minus 1. What does this mean? This means that if this game is played again and again, several thousand times, eventually this is going to be the result, minus 1. In the earlier game, it was positive 1. In this game, it is negative 1. But to prove that this figure is correct, we have to run a simulation. So see, in earlier game, we had written these lines. Now, everything will remain same. We will change the value for these variables And instead of calling it game 1, we will call it game 2. So wherever game 1 is there, it will become game 2. And these values we will change. And this time we will call data frame as df2. Now earlier it was df1. So before we will start writing the code, let us discuss about this file. This file contains the content pertaining to the law of large numbers, and this also contains the coding for the video named expected value number 1. So these are being kept in this file, and let us work out on this scenario. Okay, so everything has been copied over here. As I said, game 1 has been renamed as game 2. Data frame df1 has been renamed as df1 has been renamed as df2. So game 2 fee. See, in game 1 we had no fee, we wrote 0. Game 2 heads. If one gets heads, he gets $10. Same was the case in game 1. In game 1, if one gets tails, he loses $8, and here there is no loss, zero loss. So that is a difference. So we have written these values accordingly. And we are going to play this game 1 million times. Okay? We will play this game 1 million times. And all these lines have already been written. So let us run them one by one. Let us discuss and get to the conclusion. So let us bring these lines. Okay, fine. Now let us execute this and just see. Let us make some room. Okay. Now see the value for x. See, x is nothing but a random variable. So we are flipping a coin several times, right? So this is the result. Tails, heads, heads, tails, etc. We will make a data frame for this and see how our data frame looks. Okay? Tails, heads, 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 tails, so on and so forth. Then we will do what? Exactly as we did earlier. We are not going to change anything whatsoever, right? So what is this doing? If it is tails, we will write 0 alongside this column. And if we get heads, we will write 10 alongside this column. And the column will be named as game 2. Just see, this is how it looks. Sorry, df2. Correct? So tails 0, heads 10. So wherever we have heads in this column, just beside it, we will write 10. And the column name is game 2. Correct? Good. Next, fee. What is the fee amount? 0. Okay. Let us run this. Now we have third column. And okay, this is fee is not 0, 6. Earlier it was 0. Now it is 6. Sorry for that. So game 6, game 2 fee column will have 6 in each and every row. Fine? Okay. Next, what is this? Game 2 net gain. What is going to be the net gain? Let us see this. Let us run for, let us see 5 rows. See, tails, game 2, since it is tail, it is 0. Fee is 6. So what one gets if one is seeing tails, loses $6. If it is heads, the player wins $10. He has to pay a fee amount of $6. Net gain is 4. So on so forth for every play, right? Each row is representing one play, one flipping of the coin. Fine. Now we have many records over here, right? I think 1 million records. Let us see the tail of this. Tail means last 5 record. Of course, we can change it. We can write 1 or 10, whatever, but by default it shows 5 records. See, how many times? It is actually 1 million flips. What we will do, we can now calculate the expected value as we did earlier. We will say sum df2 game to net gain total. This is the value. We will divide it by this, what? 1 million. What we are getting? This is almost 1 minus 1. And what we were expecting to get? We were expecting to get minus 1. And we indeed got minus 1. Almost, right? Now we want to draw a line chart and see the curve, how initially it will go through the turbulence, but as the number of flips increases, it will settle at minus 1. So we have to demonstrate that. So for that, we need 2 columns. What will be those columns? See, the columns will be cumulative net gain. Let us bring this here. Let us see data frame now. What is this column? Look, minus 6, cumulative minus 6. Now 4 comes. What will happen? Minus 6 plus 4. What is the result? Minus 2. Then minus 6, 4 is minus 2. Then 4 positive. Now we'll get positive 2. So this is basically nothing but cumulative total of these columns. Look at this. Next, what we will do is we will start calculating expected value for each and every row. How that is done? Let us bring that line. It is already written. Okay. See here. What does this do? It says df2 cumulative gain. This gain we will divide by the flip count. Now, what is the count of the flip? First. So it will be 1. It will be divided by 1. We will get what? Minus 6 only. Then this will be divided by 2, then 3, then 4. And last, this number will be divided by 1 million. So we will see the result. Let us create that column. Let us go to that column and just see first few records, 5 records. Look, when we divide by 1, we will get minus 6. And then here, what we are getting? We are dividing it by 2. Correct? Minus 2 divided by 2. This is what we are getting. So what will happen? See, this particular column is a cumulative gain. It is going to increase, right? And then the number of flips is also increasing. So let us go and see last few records, that is last 5 records. So what will happen? Look, what we are getting. See, the cumulative gain is minus 997240. We will divide this by 1 million. We will get minus 0.997240. This is the result. This is the end result, right? It is equivalent to writing this sum df2 game 2 net gain we already did on top. Again we are doing, and we will divide it by n, right? That is nothing but 1 million. Look, we are getting this. So either we take total of this, divide by the total number of flips, or we do this cumulative gain and keep dividing by the number of flip again and again like this, and at the end we get this result. Good. So we had done this earlier. Now we are ready to draw a graph, and we will be drawing graph for this. This is the column which goes through a lot of turbulence in the beginning. Look, see, minus 6, minus 1, then 0 0.6, 1.50, but eventually it will settle at minus 1. See, all these are minus 1. Let us see more record. Let us see 20 records. See, all are minus 1. Okay, but in the beginning what is happening? It is going through a lot of turbulence, correct? So let us draw a graph. What we will do? Already we did earlier for game 1. So we will simply copy this code, okay, and run here. Where is that? Here. Here we will run. So what is this loop all about? Initially, the graph will be drawn, the line graph will be drawn for initial 100 place. Next, it will draw the line chart, line graph for initial 500 games, then for 1000, and then for total number of place. And this is how it will be. What happened? We should not write df1, it should be df2, correct? We copied from there and we have to change. So, okay, df2, not game 1 but game 2. Okay, good. See, it is going through a lot of turbulence. This can be compared with head. See, point minus 6. Is it minus 6? See, this is minus 6. Then jumping here, what was that? Minus 6, that minus 1. It went to. Now, see, the problem over here is it is very condensed, right? There are 20 flips from here to here. We cannot really eyeball all these values. But you can see minus 6, it is started from minus 6. And it is going through, look, too much of turbulence, right? Zigzag. And then when we see 500, then 1000, then all the see, it is gradually starting to settle at minus 1. But still it is going through some turbulence. More number of flips, that is 1000, it is starting to settle. And then when it is 1 million, just see, it got completely straightened at minus 1. So we have proven that for game 2, the expected value is minus 1. And for game 1, the expected value was 1. So if we were given a choice to, to select any of these two games to play, one should always select game number 1, because there we would be having the probability of winning $1 if we play many games. But here the probability of gaining is not there. We will, if somebody plays this game again and again, he will lose eventually $1. Okay, so this file is ready about this expected value 2. Now what we will do is these lines were written only to explain. So let me remove them, all of them. Okay, all of them. We will retain only the part pertaining to the chart. All other things we will remain. Okay, so that this sheet is neat and clean. Let it be like this. So I run this, run, run. Ready. So these cells pertain to game 2, and we call this file as expected value hash 2, and expected value hash 1 pertains to game number 1. And then we have these cells pertaining to the law of large numbers, which was discussed earlier. I hope now we know how to calculate expected value for any given scenario. We will have more videos on expected value, and we will discuss other things like we use only coin for both these games. We can consider a die and several other things, but that will be coming up in future. Thanks for watching, and I will see you in the next video.